Hey everyone, I'm Nitish Manocha from New Delhi, India, and I'm building ARES, a free-floating intelligent robotic system with two 7 degrees of freedom robotic arms to autonomously inspect, repair, and maintain spacecrafts in orbit. Think of it like a satellite, but with two robotic arms, and instead of Earth, it is orbiting around another spacecraft or space station. But you might be wondering, why build something like this? So, for a second, let's consider ourselves in the shoes of Sunil Williams and Barry Wilmore, who recently went to space aboard the Boeing Starliner mission. Due to a series of malfunctions, including thrusters going offline, helium leaks, and software glitches, this spacecraft was deemed unsafe for human return flight by NASA. This could have stranded the two astronauts in space, but fortunately, SpaceX is there to help and bring them back next year. However, external help is not always going to be an option, specifically when we venture deeper into space beyond the low Earth orbit. Moreover, with the recent advancements in robotics and AI, we don't have to surrender to equipment failure like this one in our journey to become a truly spacefaring civilization. Us humans have also been living continuously in space aboard the International Space Station since November 2000. So we already do use robotics in a similar way, with the two best options for inspection and repair being human EVAs and robotic arms like Dexter or Canadarm. But these options are not perfect, with the human EVA being incredibly risky and costing anywhere between $20 to $100 million per EVA, and the robotic arms being constrained to the body of a spacecraft, which in this image is the ISS. So, inspired by NASA's Astrobee, which is a multi-purpose robotic assistant for astronauts inside the ISS, I came up with a solution which merges the best of human mobility with the capabilities of robotics, and hence ARES, a free-floating intelligent robotic system with two 7 degrees of freedom robotic arms to autonomously inspect, repair, and maintain spacecrafts in orbit. I designed it to be very mobile, with the two arms having freedom to move in 7 different axes, similar to a human arm, and ARES will also have a boxy shape to accommodate to its many different hardware components, which include coal thrusters for moving around in space, dual cameras for stereo vision and depth perception like us humans, thermal cameras to check for leaks and anomalies, night vision cameras for inspecting darker areas during shade, UV sensors and spectrometers to check material degradation over time, LiDAR for 3D mapping the entire spacecraft and obstacle avoidance while traveling in microgravity, accelerometers, gyroscopes, and IMU for maintaining orientation or attitude of the robot, and GPS for precise positioning in space. It will also have onboard computers for navigation and running all of these sensors, because these sensors are a very important part to ensure the robot is reliable and accurate while working in space and while collecting all of the important data to send back to ground control. So I talked about the hardware, but one of the biggest challenges for building something like this is making the system autonomous and reliable in space. I plan to solve it by not just having the best hardware for the job, but also making it smart. It will use machine learning along with computer vision to analyze the data collected through different sensors, identify anomalies in those data, and then classify damages to trigger the right action. It will also utilize deep learning algorithms to make autonomous decisions and travel in microgravity. I plan to use algorithms like HectorSlam to ensure the robot can navigate reliably. HectorSlam is one of the algorithms that NASA and other space organizations use to land its landers on the far side of the moon. These are my next steps. I'm currently at second phase where I'm beginning to test the design with simulations in ROS and Gazebo. The next step will include physical prototype development, then field testing, spacecraft development, test deployment, and then the first customer acquisition. I'm also currently talking with different universities and space organizations in India to help with the funding and space for the prototype development. I love this slide and this quote. Any inefficiency is an opportunity to make things better, and literally took it to heart while ideating this solution. This solution doesn't just solve the near-term challenge of autonomous inspection and repair, but also paves the way for a safer future for human spaceflight. I envision hundreds of such robots being developed and deployed in space to conduct round-the-clock inspection on all of our most important space infrastructures, ensuring maximum uptime and minimum losses. You can also see a few robots around the space station in this design. Now, last but not the least, I'm Nitish Manocha, a 19-year-old space technology enthusiast from New Delhi, India, with over 6 years of project experience in robotics and AI. I'm passionate about the potential of advanced robotics to revolutionize space exploration and the impact robotics and AI can have on our lives here on Earth. So if you have any questions or just want to connect, feel free to reach out to me on my LinkedIn or on my personal email. Thank you.